So my main research theme is to understand how biomechanical force that involved in developmental stage of the heart. So we are using a zebrafish as an animal model. So the advantage of zebrafish is their body is transparent when they are in embryonic stage. So we can access those kind of structural information with optical system. So the first project is to develop the high resolution microscope. So one of my PhD students and postdoc is to develop the high resolution microscope technique with machine learning technique that can create the resolution under the cell, so we can track the cell signaling or molecular signaling with developing live heart of the zebrafish. So that's one of the project going on. And later, based on the image, we quantify the biomechanical forces such as blood flow inside of the heart and contraction of the heart, how those kind of mechanical forces that contribute to the morphology of the heart, and eventually how those kind of mechanical force that interact with chemical signaling like molecular signaling or cell signaling, they can design the shape of the heart. That's the main theme of my research. So as a biomedical engineering research lab, we need a lot of different background people. We need like mechanical engineers, biomedical engineers, electrical engineers, and as well as computer scientists.
What inspired you to do this particular amazing research activity?
Yeah, so that has been studied since when I was a PhD. So I originally studied with atherosclerosis or human cardiovascular study. So when I joined the PhD program, I realized that I want to study more into the heart. So the heart is fascinating organ because it's a dynamic sample, not like other organ systems. So zebrafish research finding is greatly translated into the higher level of animal, because the mouse sample or rabbit sample or the like human sample, so we cannot see through, right? But zebrafish, with the microscope system, we can see through the heart, cardiac structure, and then we can track up the cell signaling or molecular signaling. So after we find out that how the biomechanical force that interact with the chemical signaling, then those kind of signaling process can be translated into higher level of animal like mouse or rabbit. Later, that can translate into the clinical trial. That's my ultimate goal of my research.
Okay, perfect. And finally, how is UTA supporting your research?
After I joined UTA, developed a zebrafish facility for my research. They provide me big lab space, and they provide some like research fund to build my lab space. So that was very helpful for me to continue my research and keep going on my research interests.